Hi guys! In this video, we're going to talk about what it means to be a solution to a linear inequality. It's a little bit different than what we're used to. Normally we're used to there being one number for a solution or maybe no solutions, but linear inequalities work a little bit differently. Because we are graphing on a coordinate plane, in these problems our answers are not going to be a single number, they're going to be an ordered pair. And so the question that I'm posing to you is, how can you tell if an ordered pair is a solution to a graph? So there's two different ways that you can tell if an ordered pair is a solution to a graph. First, you could graph it and see. So you could take your equation and you could graph your equation and see, does the ordered pair land on the graph that you drew? Now, for an inequality, that means, is it in the shaded region of the graph? Or it could also be on a solid line. A solid line means that every dot on that line is included as part of your answer. A dotted line means this is not actually part of your answer. You can get really close to the dotted line, but if you're actually on the dotted line, it's not part of your answer. So let's take a look at a couple pictures. In this example, anything in the red shaded area is a solution to this problem. For instance, the ordered pair 5, 0 right here would be a solution. Or up here, 5, 5 is a solution. Anything in the white area is not considered an answer. It's not a solution. So the origin is not, 0, 5 is not. And then since this line is a solid line, I could also pick points on my solid line and say that those are solutions. For instance, the y-intercept, which is at 0, -3, that is a solution. I don't really know what the x-intercept is, but right here would be a solution. So you can also pick any points on the solid line and say that those are answers. They are true. They work for that problem. Here's another example. Now again, on this example, anything in the blue shaded area is considered a solution. So over here, this one also 5, 5 is an answer. Over here in the white area, none of those are considered to be solutions or answers. Now, because the blue line is a dotted line, we cannot say that any dots on the dotted line are a solution. So if I'm looking at my y-intercept up here at 0, 5, since it's on the dotted line, that is not an answer to this problem. 0, 5.1 is an answer, so you can get like really close, but not actually on the dotted line. Okay, so again, shaded area and solid lines are solutions. The white space or a dotted line is not a solution. Now this works great if we've given you a graph, but if you don't have a graph to start with, maybe you don't want to draw a graph. And so another way that you can tell if an ordered pair is a solution is by taking the ordered pair and plugging it in. So if we give you an equation, you can plug the ordered pair into the equation and see if it's true or false. If it's true, it is a solution, and if it's false, it's not. Here is an example. So again, this one says, is -6, 1 a solution for this inequality? And you can do this with inequalities or with equations also. So if I give you something with an equal sign, you could also plug it in to see if it's a solution. Now, when you're plugging in, you have to be very careful and make sure that you're plugging in the correct number to the correct letter. So -6 is my x coordinate, so I will be plugging it in where the letter x is. And 1 is my y coordinate, so I will be plugging that in where the letter y is, like so. Next, I'll simplify each side individually until I have a single number. This inequality says 3 is greater than -42. Well, that's true. 3 is bigger than a negative number. Since it is true, we would say an answer of yes. This is a solution. So the question was, is it a solution? And the answer is yes. That also means, again, if we were to graph this, and we would want to change it to graph it, but if we were to graph this, that means that -6, 1 would be in the shaded region of your graph. This concludes our second video. You should now be able to finish your homework.